statements. And variables are a place of how you keep track of data, where you store different pieces of data in memory while you're running your program. Variables have 4 properties that you need to know this for the test. They have a name. You give it a name so you can refer to it in your code. So you can say, well, that string that I stored over here, we're going to use it as the player name over here when we display it on the screen or something like that. They have a type. We're starting with the types string and int. There's a boatload of other types. We're starting with string and int just to kind of get you started with a little bit of reason. The type is basically telling the computer program, this is how much memory I need you to set aside because I'm going to be putting in a whole number, an integer, or I'm going to be putting in a whole string of characters. Hey, Taylor. Let me give you one of these. And your ticket for that you're late? Okay, well, that's okay. I didn't mark you late. If that's what this is about. Okay. So the type is important. If you say, I'm storing an integer here, and you try to cram a name, like a player name, inside there, the program is going to stop you. The compiler is going to stop you and say, you don't know what you're doing, bud. Stop. Don't do that. You can't do that. I'm not going to let you pass. Integers. It's important to know about integers. Integers are whole numbers only. There's no decimals in integers. So you can store 1, 2, 3, 4, up to 4 billion something or other. You can't store 3.14. You can't store, 1.5. No, you can't do that. It only stores whole numbers. A value. So you have a name, you have a type, and then you have a current value. There's always some current value in this storage space. When you first create it, it puts some default value there. And finally, it has what's called scope. Scope is how long this variable lives. What's its lifespan? And the lifespan is noted by areas of code in your program. It'll make more sense later. We're not going to talk a lot about scope today. I'm saving that for Wednesday. So when you give a variable a name, there's certain rules that you have to follow. And then there's certain rules you ought to follow so you don't lose points. Let me explain. The syntax is the strict rules that the compiler, Visual Studio, will enforce. And if you don't follow these, the compiler will stop you and say, I don't know what you're talking about here. This is not a variable name. If you think this is a variable name, this is not a valid variable name. And it won't compile. It's enforced by the compiler. The identifiers, or the names, name and identifier are kind of used interchangeably here. The name can only contain letters, numbers, and underscores. Cannot contain anything else. Letters A through Z, upper or lower case. Numbers 0 through 9, and underscores. It can't contain a dash. It can't contain a hashtag. It can't contain an apostrophe. You can look at your keyboard and choose all the other things that it cannot contain. So it's pretty simple. Letters, numbers, and underscores. But one extra rule here is it cannot start with a number. We'll go over some examples here. So that means that you can't name a variable 8, the number 8, Fred. But you can call it Fred 8 because Fred, F-R-E-D, is letters. 8 is a number, so the 8 can come later. Or it can be F8, but it can't be 8F. And the case of the variable, upper lower case, matters. Matt with a capital M is different than Matt with the lowercase m. It treats them, they're different names as far as the computer is concerned. So my variable, capital M, capital V, is different than my variable, lowercase m, lowercase v. Now so we went over the syntax here, which is enforced by the compiler. The convention is a strong recommendation that in this class becomes a points killer if you don't follow the convention. This is enforced, so it's to help you not get confused. You can, if you wanted to, you could name a variable xxyz3. You can go, oh, that's where I stored the variable name. No, that was xxyz2. xxyz3, oh, that was the password. You can confuse yourself really bad if you give it really lousy variable names. So the convention is enforced by me. Oh, okay. It should generally be something that indicates what this data is for, what it's being used for. If you're storing the player name in a variable, you might name the variable player name. If you're storing the score in a variable, you might name the variable score or something like that, or total score or something like that. We also use a convention that's called camel case. And this helps to differentiate different names in your code a little bit better. Camel case, it follows this kind of convention that you see here with the word camel case. Starts with a lowercase letter, and then each subsequent word starts with a capital letter. So player name would be player, all lowercase, and then N in name would be capitalized. That's called camel case. And try to stay away from non-standard abbreviations. That's not really that enforced by me, but camel case will be enforced by me. And if you're giving it really meaningless, if you're calling it XX3, I'm going to say, what does that mean? Is that an abbreviation for something? Oh no, I just know what XX3 is. I thought that was coming up earlier. Anyway, so let's go over a couple of suggestions or examples real quick. So if I am dealing with different variables like player name, I told you it would be something like this: player name, or score, all lowercase letter, or my variable. That's not a very meaningful name, but that is following the camel case where this is lowercase and this is uppercase. You might have something like, this is my score. Something like that. Every word after the first word is capitalized the first letter. First letter of the first word is lowercase. It's okay to use a simple letter as a variable name. You could use I or X, so long as they're lowercase. So if you're naming a variable and it's just I and you use a capital I, that's incorrect because for camel case, the first letter is supposed to be lowercase. We'll have some more examples here in a minute. Making sense so far? A little bit? No hands? Type, we've talked about int, it's whole numbers only, and string, which is letters only. String, it's enclosed in double quotes, except for this special one, which is null, all lowercase. I'm going to show you how all this kind of comes together here in just a second. Null means I'm storing nothing here. No string is found here. Integer, it always has a value. By default, it's given a value of 0, but you can say it's -1. I'm going to assign it to -1, or you can do some math calculation and it comes out to be 47. There's a whole bunch more we're not going to be discussing today, but they'll come up later in this course. Now, an expression is where you have, think of it as like an algebra expression. where you give it some formula that calculates to something. Expressions always calculate out or evaluate to a single value, and they have a type when they're done. It has to have a type. In our world, there's only two types currently, integer and string, so whatever your expression is going to end up being an integer or a string, if you're adding something to it or modifying it in some way. And you can use operators to combine expressions. This is going to make more sense here in just a second. For instance, in math, there's the addition operator, plus, that takes this expression. So this expression all by itself is the number 10. It's an integer. It has a value, 10. It has a type. It's an integer. This is an expression all by itself that is an integer, and it's 3. Combine them together with the addition operator, and the answer is 13. Whew, thank you. Not too hard. Subtraction operator, 10 minus 3, 7, right? Multiplication, we use the asterisk for multiplication. 10 times 3 is 30. Making sense so far? This is pretty straight algebra. Slash is the division operator. 10 divided by 3. Anybody want to hazard a guess? Maddie? 9.3. Not. It's all right. Okay, you're both wrong. You're wrong again. So this is an integer 10 divided by an integer 3. What type is it going to give me? It's going to give you an integer. If it's giving me an integer type, all these rest have gave me integers. If it's giving me an integer type, what is the correct answer? 3. You get it? It just lops off whatever the decimal is. It's not rounding it or anything. It just cuts it off. So if it would have been something that would have been 7.9, it would have been 7. It just chops it off and throws it away for any decimal remainder that's left over. Anybody want to guess what the next operator is? You got add, subtract, multiply, divide, and modulus. Of course. You guys should have known this. Modulus is the percent sign. And it's basically saying you can kind of, if you take the little zeros off, it's kind of a division. That should be kind of the way you remember this. It's doing 10 divided by 3, but give me the remainder. So if I do 10 long division divided by 3, you remember how to do this? It wasn't that long ago you were in elementary school. See, 3 goes into 10 3 times. That's 9. And it has a remainder of 1. The answer is 1. It's not the decimal part, 0.33. It's the remainder. It's the whole number remainder from the division, long division. Okay, so when you see this, think of it as division, 10 divided by 3, but just give me the remainder. I don't want this part. I'm sure it has a name, but I don't remember what it is. Yes, Tom. So, let's say it's 10 divided by 5. There is no remainder. It's 0, right? The remainder is 0. If it's evenly divisible by that number, you can quickly see that. Making sense so far? I'm looking in your eyes. I can't see your faces. Okay. You'll need to know all 5 of these, and you will be using all 5 of these along the way in this class. Now, string operators operate a little bit differently. Hey, I've seen this plus sign before. It's the same thing that I saw before, but now if it's associated with a string on either side of the plus sign, that's very important. If there's a string on either side of the plus sign says, I am not doing mathematical addition, I am doing concatenation. Concatenation just simply takes the two strings or the two values and just glues them together. So this would be cute. Right? It just glues them together like a train, whatever you want to think about it. So the string 1, 0 and the string 3, what's the answer here? It's 103 as a string. This is going to be a trick question on a test. You'll get the points if you remember these little tricks right here. Is this still concatenation? It is, because a string is involved in the expression. It's either on one side or the other. Because a string is involved, it's concatenation. It's not mathematical. And so Visual Studio, the compiler, automatically says, okay, well, I'm going to take this integer and automatically, because of the concatenation operator, I'm going to automatically convert it to a string and glue them together. And so this, too, is 103. This will be a trick question on the test. This is the same thing that I just did, only it's integer and a string added together. It's still doing concatenation, and it's still 103. Now, what's this one? It's a trick question. It is not concatenation. This is doing math. Because it's an integer plus an integer. Oh, that means I'm doing addition, and it's 13. I'm giving you free points on the test if you remember the difference between these two. You'll get points where other people crash and burn. Any questions? This is where we get to have fun. I'm going to code. Operator precedence. Is it PEMDAS or what's the order of operations? PEMDAS? Okay. So if I gave you an expression like this, you're going to start going, I can figure it out. So how do I evaluate this? Do I go left to right to left, start in the middle? Left to right. So if I did left to right, I would first take this expression, 4 plus 3, that's 7, times 2 is 14, divided by 3. 14 divided by 3 is 4, minus 1. So that would be 3 if I went that way. You see how I just went left to right? You saw how I did that? Okay. What if I do right to left? So 3 minus 1, that's 2. 2 divided by 2 is 1, times 3 is 3 times 1 is 3, plus 4 is 7. So that's a different way of evaluating. Are either of these correct? What's the right way of doing this? You do multiplication and division first. They're here in the middle. Does it matter which one I do first? Left to right. When they're of equal precedence or equal priority, you just do them left to right. So I do 3 times 2, which is 6, divided by 3, which is 2. So it's 4 plus 2 minus 1, 6 minus 1. The correct answer here is 5. See how I did that? Did I go too fast? Anybody want me to do it again? Slow motion? Okay. So the order of operations matters, and this will be on the test. We already just established it's a 5. First priority is multiply, divide, and mod. These are all division multiplication operators. That's first priority. Second priority is plus and minus. You always do it left to right. Now, just like you can do in algebra, you can override behavior, and you can say, if I put parens around this, that means you do the stuff that's in the parentheses first, and then you follow the order of operations. Okay? A statement is a single complete instruction for the program. You're not going to recognize these yet, but statements always end with this semicolon at the end. You typed a whole bunch of statements in Draw a House. You said blue line equals new pen, open paren, XYZ, close paren, semicolon, next line. That one line with the semicolon at the end is a statement. It essentially says, this is one line of instruction that the compiler looks at. He might make a whole bunch of instructions out of that one line, but as far as you have typed, you've given it one complete statement that it will evaluate. These curly braces are super, super important. They always match. There has to be an open curly brace, and if there's an open curly brace, there has to be an equal number of closing curly braces. It's just the same with parens. If I have 4 plus 3 minus open paren, 7 times 5, close paren, that doesn't work. You have to have an equal, always matching. It's the same with double quotes. Same with a bunch of things. These braces are really important. In your Draw a House program, along the way, some of you ran into problems when you accidentally deleted one of the curly braces. Well, now the compiler was like, I don't know what you're doing now because I got an open curly brace but not a matching closed curly brace, and it just totally got out of kilter. So when you have statements in a block is identified by an open and closed curly brace. They're executed in order, top to bottom. We'll go over how this all works. An example of a statement. Now we're putting together, here's the first lines of code. Deep breath. This is saying I'm creating an integer variable. I'm giving it the value, I'm giving it the name I, and I'm assigning it an initial value of 29. So this says I'm creating a space in memory that stores an integer. I'm giving it the name I, and I'm putting the value 29 in there to start with. All of that is done by this single statement or this single line. This is an example. Now, we didn't talk about this operator. We talked about the mathematical operators. We talked about the string operators. I even kind of hinted on the paren operators for overriding precedence. But there is an operator called the equal sign. It is called the assignment operator. It is the only assignment operator. We have the mathematical operators. We have the string operators. This is an assignment operator. An assignment operator always takes the value of the expression that's on the right and assigns it to the variable on the left. That is the only thing that this does. Now, the type of this expression, remember, expressions always have a value and a type. So the type is either integer or string. And so if the type is integer, then this value or variable, this variable needs to be of type integer. If it's of a type string, then this guy needs to be a string over here, a string variable. Now you can have the variable, you could say, I'm creating a string variable s. That just simply creates the storage space. And then later on in your code, you can say s equals double quote player 1. That takes this string expression and stores it in that variable s. So the assignment operator. So you've learned about 3 different types of operators today. There's the mathematical or arithmetic operators. There's the string or concatenation. Typically, it's just the concatenation operator. And we've learned about the assignment operator. So this is declaring a storage space to store a string with no initial value. So no initial value means that we've created a storage space, we've given it a name, but to start with, it has null, means it's empty. It has nothingness here. There's nothing here. It's not the word null. I mean, that's what you type in your code, but it's given a value of nothing. So this one gets to be a little bit of fun. This is saying this string variable, stir, is going to get the value of this expression. Well, this expression is actually, there's that expression plus that expression. If I was to parenthesize it the way it would be evaluated. So it starts by saying, takes the string Mr. Brooks is, and concatenates, because there's a string involved, it concatenates the string value of I, this integer, which is 29. So it's going to start off by saying, Mr. Brooks is 29. And then that's what is done with this, and then it's going to add years old. Put all that, and then assign that into string. See how I did that? I wish it were a true statement, but so here's a little more complex one. Int value. We're creating a storage space called value. That's a type integer. We're going to assign it the value of this expression. Well, the overall value of this expression had better be an int, or the compiler is going to stop you right there and give you an error. So I, we know, is 29, because it's assigned up here. To preserve the order of operations, I do 29 divided by 2 first. So that gives me 14 plus 32 is 46. So value will have 46 to start with. Make sense? What else do we have? Okay. In our calculator program, you're going to be getting this assignment shortly. In the calculator assignment, you're going to be interacting with text blocks and text boxes. I will walk you through the first time on screen. But the text block, so this is looking like, what in the world is that? This is the variable name. In this case, I called it text block. Notice how the T is lowercase here. Block is capitalized. And then there's this little thing that says .text. .text means this is a sub-variable, if you will. It's called a property. It's a sub-variable of the text block. The text block actually encompasses a whole bunch of variables inside of it. There's a variable inside of it called text. It's okay that it's capitalized when it's used as a property, capital T. And it's just saying, take this string, some text, and we're going to assign it into the text block text property. And then later on, I can take the text property as though it's a variable, it's a string variable because it's part of text box, and I can assign it to value and go use it like I normally would. Now, when we're dealing with strings, when someone types a value into my program, my calculator program, it's coming in as a string. It's a string of characters. They might type a string of characters of 1 and 2, but it's a string 12. Well, I want that 12 to be converted to an integer It's a string right now. I want it to be an integer 12. To do that, you run it through this thing called convert to int32. We don't need to get into the reasons why there's a 32 here. You don't need to know that for today. It'll just confuse you. But this takes a string variable. See how we took the string that was typed in a text box, because text box is where you can type. It took the string that was in the text box, put it in a value, then we took the value, the string value, because this is string, and we ran it through this converter code that's going to convert the string value into an integer number. So if they initially typed 1, 2 in the text box, string value is the string 1, 2, but then it's converted to converted to the number 12 and stored in num. This line will be very important to you in the calculator assignment. Okay. To save time, we're going to just have you pass all your... You should have the worksheets done. Anybody need more time on the worksheet? What did I not cover in the worksheet? Oh, let's go over some of the things in the worksheet. All right, let's have some fun. Okay, in the worksheet, I'm going to go over these real quick. Hopefully it's quick. Okay, here we go. If you haven't already, get Visual Studio kind of loading in the background. Okay. We're going to walk through this real quick. It says I want to write the C# code for doing each of these things. I want to create an integer variable named myScore. That should be pretty straightforward. So we know it's an integer, so we type int, and we want myScore. And a semicolon at the end, because that's the end of this statement. That is the line of code that will create an integer variable named myScore. Create a string variable named player name. This is pretty much the same thing. String player name, semicolon at the end. P of player name is lowercase. Assign a value of 42 to the variable named answer. We're going to assume that the variable answer has already been created, because it didn't say create a variable named answer. So I'm just going to assume that the variable answer has already been created and it's of type integer, because that's what we're going to do. We're going to say 42 semicolon. So 42 is being assigned into answer. Create a variable that will keep track of how many cards have been played. Okay, so now this is going to force your creative mind to say, okay, what type of variable do I want to use for tracking how many cards have been played? Integer or string? Integer. You technically could use a string, but it would be much more cumbersome. So we're going to create an integer variable. What should we name it? It needs to be meaningful, has to follow camel case rules, and all the other variable naming rules. Cards played. How would I spell that? Okay, and then a semicolon at the end. You don't have to name it cards played. You could name it how many cards have been played. I would not suggest that, but you can if you really are a typist and love to just go to town on the keyboard. Okay? Technically, you could say, okay, how many cards? So we called it cards played before. A variable that will keep track of how many cards have been played. It could be played cards. You could, or card count. You could name it a whole bunch of different things. Just make sure you end the line with semicolon. Okay? let's go to this next part of the worksheet. Get that out of the way. Here's a program. We have these 3 lines that are considered these part of our program. This creates an integer variable called size. It has a value of 10. Integer variable called count has a value of 7. String variable called name has John in it. It says 4 plus 10 times 3 minus 2. What's the value there? 32. So I would do the multiplication in the middle first, so that's 30. Plus 4 is 34 minus 2. It's 32. This one is the same numbers, but because we have parentheses, it's overriding the normal behavior and saying, okay, 4 plus 10, that's 14. 3 minus 2, that's 1. 14 times 1 is 14. Size divided by 3. Size is 10 divided by 3. Maddie, here's your chance for redemption. Size divided by 3.
3.
Perfect. No decimals. Hello, comma, space, in the quotes, plus name. So that's going to say, hello, comma, space. I'm putting an underscore for a space so you see it. John. Close quote. Because name is John. We're just concatenating those 2 together. Count mod 2, or the modulus operator. Meredith?
1.
So count is 7. So 7 divided by 2, what's the remainder? Well, 2 will go in there 3 times, that's 6, with the remainder of 1. Exactly right. Size mod 2. 10 divided by 2, what's the remainder? Is 0. Okay, we're all getting this? This worksheet is a gimme. All right, now we get to the fun part. You have a window with a text box. So I'm going to just draw this so I can kind of have a visual. I have a text box. This is where people can type things. And it's called text box input. Text box input. That's what that's named. And a text block named text output. A text block, I'm kind of drawing the same thing, but this one, well, how do you draw a text block? I'm just going to put X's here, because this isn't where you can't type here, because it's a text block. And I'm calling him text output. With me so far? Display the message hello in the text block. The text block is called text output, so I would say text output dot text. This is the text that it's displaying, is equal to quote hello, semicolon at the end. Make sense? I try to look at your eyes and try to discern your confusion level. Assign the text typed into the text box into a string variable named name. So just for clarity, I'm going to have a string variable called name is equal to, I'm kind of starting at the end of the sentence and going backwards. I have a string variable named name, and it's getting an assignment. Assign means equals. And from the text box is called text box input dot text, semicolon. So that's taking the text of the text box and assigning it to name. Make sense? Convert, remember that convert one that we had on the previous slide. Convert from the text box to an integer and assign it to a variable named age. So I need an integer variable called age, and I need it to convert the text from the text box. So I say convert dot to int 32 open paren. and I'm going to take the text box, the text that's in the text box. Text box input dot text. So this is taking the text that's inside the text box, running it through the conversion, so it's string, converting it to an integer, storing it into age. Display the message, hello, XXX, in the text box where XXX is the value of the string variable called name. Okay, so the text block is text output, and we say dot text is equal to something. Well, we want it to say hello, and we want it to say whatever was put into name up here. So I need to do the string concatenation thing, and I need to say hello in quotes, comma, space, close quote, plus. That's a plus sign. And I want it to be name. Semicolon at the end. Making sense? The last one, you are XXX years old in the text block. Well, the text block, again, is text output dot text is equal to, now this is a little bit more complicated string concatenation because we have kind of three parts. We've got this first part that's text, this last part that's text, and this part that's coming from a variable. So I'm going to put quotes, you are, there's a space there, close quote, plus, years old is coming from the value that was age, plus, open quote, a space inside there, years old, close quote, semicolon. Okay. I need a drink. Everybody got it written down? Can I erase it? Moving forward? Any need some time? Got it? Okay. I'll start erasing from the top. And then walk in front of the text that you're trying to type. You're going to hold on to these worksheets and give them to me on the way out. Oh, good. Okay. Okay, let's see if we can do this. Say not now, right down there. You pass those down your row. Choose C# up in the development settings. Say C#. 1, 2. Yeah, Visual C#. And then you can choose any color thing. Take one, pass it down. 1, 2, 3, 4. Where's Abby today? She's missing some good stuff. That might be 3 or 4. We'll try. 1, 2, 3, 4. 1, 2, 3. Thank you. All right, this is your first real meaty assignment. That is due on, is due on September 9th. You can write that at the very top where it says due date. You'll want to know that for reference. Due September 9th. We only have 10 minutes. We're going to get started anyway on this assignment. You should have Visual Studio up and running. You should have your thumb drive plugged into your machine. Oh, mad scramble. I should have mentioned the thumb drive earlier. Oh, I didn't. Did I give you one? I did. Okay. That should have your beautiful lanyard attached to your thumb drive. That's my computer. Okay. We're going to create our first real assignment project thing. Everybody okay? Got the thumb drive plugged in? A little bit of mad scramble. First time the machine's recognizing the thumb drive. Okay. From Visual Studio, we're going to start kind of like we did with Draw House, but don't get ahead of me because you'll take the wrong fork in the road. Because this one's going to be a little bit different. Okay, everybody ready to go? So I'm going to click on File up here. I'm going to say New, get rid of the magnifier. File, New Project. You get to this window. Very important. We're going to take a fork in the road here. Very important. Instead of Windows Form app, it's going to be a WPF app. From here going forward, it's always going to be a WPF app. WPF stands for Windows Presentation Foundation. It's just what we use for the remainder of this class. So that part is really important, WPF app. Then down here, for the name down here, we're going to type something meaningful. For the first assignment or two, if you turn in one that's called WPF App 1 or at WPF App 2 or something like that, I'll let it slide, but after that I'm going to start talking points. You need to give it a meaningful name, okay? This is our calculator assignment, so I'm going to say calculator. And for my purposes, because I have a lot of calculator apps on my machine, I'm going to say Fall 2020. You don't need to put the Fall 2020 on there. No spaces. Do not put spaces or any other kind of punctuation in there other than underscores. It's the same as kind of for variable names. So if you put spaces in here, you might have to recreate your project along the way. Sometimes Visual Studio loses its brain when the project name has spaces. It allows you to type spaces in there. It allows you to type dashes and hashtags in there. Don't. Just stick with letters, numbers, and if you really want underscores, don't start with a number. Okay, I'm going to zoom out for this one because my screen kind of moves. Where it says location, you need to be putting this in a location. Yo. Thank you, sir. You need to put it to your thumb drive. To get it to your thumb drive, you're going to click on this Browse button. And you're going to scroll down to where your thumb drive is. It's usually under this PC. And you're going to select your thumb drive. I don't have my thumb drive with me today. I thought I brought it, but I have Mentos. No, I don't have my thumb drive today. That's okay. So imagine that my C drive is my thumb drive. And I'm going to put it under my thumb drive, C computers. In your case, it's probably going to be D computers, or you can just put it at the root of the drive. That's okay. And so I say select the folders. So my location, you can see that down there now. Think of that as saying D computers, but that's just where your, I can raise that up a little bit. That's where it's going to put it there. Alicia? Your thumb drive, when you first put it in there, just has, it's an empty drive, D. So if you want to create a computers, we can say new folder. Now type computers. You don't have to put it in a folder named computers.
Is this where, is that my thumb drive?
That's your thumb drive, D. It'll say something like HP, garbage, garbage, letter, letter. Okay? Is everybody up to this point? Anybody have a question, problem, issue? Make some noise, raise your hand. Blink your eyes. Max, your thumb drive isn't showing up? Inconceivable. It's because your thumb drive is not plugged into the right computer. Sorry. You two are twins. Sir.
I think this is the right one.
Yeah, it is. It is. There it is. Just have to scroll. All right. Really going to get this started. All right. Ready to press the next button? All right. Make sure that create directory for solution is unchecked. It should stay unchecked from what we were doing last time. So both of these should be unchecked. Don't add it to source control. It'll just make your life miserable. Then you click OK. It is now creating the files that need to be on your system for this to begin. Got just moments. It'll take a second. You should end up with, I'm getting a new machine because your machines are faster than my machine at this point. That's not right. All right, you should end up with something that looks like this. It's important that you don't close these little windows. You can close these windows by clicking X's here and here and here and stuff like that. Don't close them, please. We can get them back. But this is your blank canvas for your calculator assignment or your calculator program. This is where we're going to put our controls that are going to be used for our calculator program. We're at the point right now where we're just about out of time. I'm going to click Start. It's up here at the top. It looks like the play button. I'm going to click Start. It's going to just compile it for the first time. You'll know things are going on when down in the lower left corner it's saying different messages. Program started, doing this, doing that, doing the other thing. And then it finally gets to this. It is my program. It's beautiful. It does absolutely nothing.